Chapter 7 Integrals, Exercise 7.2. So we have completed 24 questions. Now we will find the integral of 25th one. So integral of 1 by cos square x into 1 minus tan x the whole square with respect to x. So now to find the integral by substitution method, the key idea is if the integrand is made up of both function and its derivative, then we can apply the substitution method. So now is there any function and its derivative? So let us select the function tan x. So now if you differentiate tan x, you will get secant square x, right? So tan x is a function and its derivative secant square x, but secant square x is not there in the integrand. 1 by cos square x is nothing but secant square x. So in the place of 1 by cos square x, we can write secant square x, right? So now we have function and derivative 1 by cos square x. We will write secant square x 1 minus tan x the whole square with respect to x. So now there is a function and derivative, but which one to select as a function t? So here we have to select this original or primitive function as t. So we know that if we differentiate tan x, we will get secant square x. But what if we differentiate 1 minus tan x? If we differentiate 1 minus tan x, derivative of 1 is 0 and minus derivative of tan x is secant square x. So even if you differentiate tan x, you will get secant square x. Even if you differentiate 1 minus tan x, you will get minus secant square x, right? So instead of just taking tan x equal to t, we can write 1 minus tan x equal to t. So let 1 minus tan x equal to t. Now let us differentiate with respect to x. So this will be minus secant square x is equal to dt by dx. So in the numerator we have secant square x dx. So you will get minus dt in the RHS. Now let us substitute. So this implies integral of minus dt divided by t square. So now this implies minus integral of 1 by t square with respect to t. So this implies minus integral of t to the power minus 2 with respect to t. So now we know the formula. Integral of x power n with respect to x is equal to x to the power n plus 1 divided by n plus 1 plus. So we cannot apply this formula when n is equal to minus 1. So we will write n not equal to minus 1. So we don't have minus 1, right? We have minus 2. So we can apply now. So this will be minus 2 plus 1 divided by minus 2 plus 1 plus c. So this implies minus of t to the power minus 1 by minus 1 plus c. And this implies minus times minus is plus, t to the power minus 1 plus c. Again this implies 1 by t plus c. So this implies 1 divided by 1 minus tan x plus c. Therefore integral of 1 divided by cos square x into 1 minus tan x the whole square with respect to x is equal to 1 divided by 1 minus tan x plus c. So this is the required integral. So question number 26. Now we have to find the integral of cos of root x divided by square root of x with respect to x. So here let us check whether there is function and its derivative both. So what are the functions we have here? We have cos root x, we have root x, 1 by root x, right? So is there any link between root x and Again 1 by root x, 1 by root x. Is there any link between them? So what if we differentiate root x? We will get 1 by 2 root x, right? If we differentiate this function. So function and derivative both are there. So let us substitute this or equate it to t, right? So let square root of x equal to t. So if we differentiate with respect to x, so you will get 1 by 2 root x is equal to dt by dx. But we have 1 by root x dx, right? So here in the numerator it is 1. So 1 by root x dx. So this will be 2 into dt. So this implies integral of cos root x is written as cos t, and 1 by root x dx. We can write it as 2 into dt. So now this implies integral of 2 is constant, so we'll write outside, this is cos t dt. Now this implies 2 into integral of cos t is sin t. We have done the integration, so we'll write plus c. So this implies 2 into sin of, so t is nothing but equal to square root of x plus c. So therefore conclusion, integral of cos root x divided by root x with respect to x is equal to 2 into sine of square root of x plus constant of integration. So this is the required integral.